If the free energy principle says anything about our experience of consciousness.
You really do want to do philosophy, don't you? To be conscious, you have to be an agent. So you have to be active. You have to have in mind agency. And of course, in order to have agency, you have to have the ability to plan as an agent.
Karl Friston is one of the world's leading neuroscientists. He's known for his work on the free energy principle, a mathematical framework for understanding our brains as prediction machines that engage with the world trying to minimize entropy and surprise. We discuss the implications of his framework and thinking on topics such as free will, consciousness, AI, dreams, and more. So, hope you enjoy the podcast. Please consider liking and subscribing if you do. Hi Karl, how are you?
I'm fine, thank you.
What is the free energy principle? Could you explain it to someone who doesn't know about it, and why is it important?
You can explain the free energy principle in two kinds of ways. There's an intuitive way of explaining it, and then there's an explanation that inherits from physics. So which would you prefer, the intuitive one or the hardcore physics one?
Let's do the intuitive one first.
Okay, so the intuitive one is a formalization of how we make sense of our sensed world, and in particular, how we choose what to do and how to sample that world, how we search for the right kind of information to update and build our world models or our generative models. And the kind of information I'm talking about can range from simply where do I look next through to which Wikipedia page or which social media channel do I commit to. So it's a description of sentient behavior, where sentient just means, in this instance, behavior that is informed by sense making. So the free energy principle just provides a way of simulating, describing mathematically, modeling, understanding, and in so doing, creating that kind of sense making. The free energy in question can be best thought of, I think, of in terms of a prediction error. So the basic idea, which dates back probably to Plato, but certainly to the era of Kant and Helmholtz, would regard sense making as a very constructive process, so that our brains are in the game of generating predictions about what I would see or what I would hear or what I would feel if the world was in this state. So we have to acknowledge that the brain is skull-bound. It doesn't have access to the outside world. All it has access to are sensory messages, pulses that go down nerve cells or axonal processes that have to be organized in a way that one can make sense of what those sensory samples are telling you about. And the idea is that the brain is a statistical organ, literally a fantastic organ, in the sense that it entertains fantasies or hypotheses about what could be out there. And then on the basis of that hypothesis or that model, I repeat, a world model or a generative model, you generate a prediction of what you would have seen if your hypothesis was right. And then you compare that prediction against what you're actually seeing or what you're actually sensing in any modality to form a prediction error. And that prediction error scores how far away you are from the best kind of explanation. And then you use the prediction error to update your beliefs, whereby I mean Bayesian beliefs, formally, beliefs that can be thought of as probability distributions, or beliefs that can be described in terms of how you represent the content of what you think caused your sensation. So it was a face out there that is also equipped with a degree of uncertainty. So hence there becomes a stochastic kind of description or probabilistic description, which we refer to as a Bayesian belief. So on that view, the free energy principle says that everything that we do and sense can be seen or described as trying to minimize this kind of free energy. And this kind of free energy is just your prediction error. It's just a way of scoring the surprise that you would have if you encountered these sensations under the predictions that you generated or that you fantasized that were the best explanation for it. So you can also read this free energy, technically a variational free energy, as a measure of how surprising these data are. And if they're very surprising, you have to change your mind. And that's called Bayesian belief updating. And once you write down the maths of this, you apply the free energy principle, then you can start to understand the dynamics and the processes, the mechanics of this kind of belief updating, literally a Bayesian mechanics, because we're working in the space of Bayesian beliefs. We're talking about belief updating of this Bayesian flavor. So that would be a brief summary of how the free energy principle works. You may be asking, well, that's fine in terms of changing my mind or do my belief updating in terms of all my internal machinations, literally changing my brain states, the neural activity that represents any particular state of my brain at any one point of time, to find the best explanation for the causes of my sensations. How does that inform action? Well, very, very simply, not only am I predicting what I can see and what I can feel, say with my skin or my somatosensory organs, but I'm also predicting what I will sense from my muscles and from my autonomic nervous system. So in order to reduce the prediction error generated in this particular subset of signals which are in control of how we move, I can either change my mind and say, oh no, I thought I was sitting like this, but in fact my body is telling me that I was actually sitting like this. A more efficient and inactive way to minimize free energy or those prediction errors is actually to use them to drive my muscles until they're reporting what I predicted. So what that looks like is that my body will comply with its predicted state. It will look as if I will be acting in a way that's fulfilling my predictions. So we can use predictions in two ways. We can use them to evaluate the quality of our current beliefs that are generating those predictions to change our mind, and that will be perception. But we can also use the predictions of our motor plant, our muscles, our autonomic nervous system, in order to provide set points that reflexively can be fulfilled. So in neurobiology, we're talking about what's called a classical reflex. In the muscle system, it's called a motor reflex. So what transpires is that a system acts simply by moving, or the brain or you and I act upon the world simply by moving, and we move on the basis of how we predict ourselves to move. We realize our intentions, we realize our predictions. So both action and perception are trying to minimize the same thing, which is this surprise, prediction error. Technically, if you're doing information theory, this would be self-information or surprisal. It's just the negative log probability of these sensory datas given my model or my hypothesis about how these sensory data were generated.
You talked there about how our brains do this. They reduce prediction error, they minimize free energy. But why do they do this? And could it be any different? And is it just our brains? Is it just biological organisms that do this? Or is it more applicable? Can it be applied to other areas?
That's a very leading question, isn't it? I'm sure you know the answer to that. So the answer is no. This kind of behaviour is universal in the sense that if you exist, you must at some level engage or be described as engaging in this kind of sentient behavior. So where you were leading me was to the free energy principle as one would articulate it as a physicist. So there's an interesting strange inversion here. So the free energy principle, as read by a physicist, would say that if something exists in the sense of possessing some characteristic states over a non-trivial amount of time, some macroscopic time, then in virtue of the fact that it just keeps itself within these characteristic states, it will always be described as if it was engaging in this kind of Bayesian mechanics or sentient behavior. So just to exist and to, if you like, evince a homeostasis of a very general sort, to keep if you allowed to think of these prediction errors as scoring deviation from the states that I would find you in, whether you're a virus or a priest or a stone, then you can always be described, if you act, as acting in order to minimize that prediction error, which looks as if you've got a homeostasis, you've got a physiology that is necessary for your persistence and your existence. So technically, the free energy principle does not say in order to exist, you have to engage in this kind of Bayesian mechanics and this kind of generalized homeostasis. What it's saying is the converse. It means that if you exist, you must show these kinds of behaviors simply in virtue of existing. So in that sense, anything must be described as, in terms of this subpersonal belief updating, and if the thing can act upon the world, not everything can. A stone can't act upon the world, but say a virus certainly could, or a thermostat could act upon the world. Then it will, just by being in these characteristic states and being a thing, then it must look as if it is acting to minimize its prediction errors under some generative model. You won't necessarily know what the generative model is, but at least you know there is a description in terms of some generative model on the inside of the thing that is provides the predictions and makes it look as if it's trying to fulfill its predictions.
Is it surprising to you? Because it's surprising to me that the free energy principle can be applied not just to what we typically think of as biological life, but to everything that exists, right? It's down to the level of physics. Does it surprise you? Is that a reasonable question?
Does it? Well, not now, no.
Okay, sure.
It might have done when I was younger, but it almost seems common sense now. And even further than common sense, it's almost tautological. There are nice ways of expressing this, in the sense that if I exist in some characteristic states, then all I'm saying is that my behavior is such that I will return and revisit those characteristic states, because that is the kind of thing I am, and it will just look as if in so doing I am avoiding surprises. I'm avoiding states of being that would render me not that kind of thing. So it's another way of looking at homeostasis. If by definition I am a human being that has that by definition, whilst I'm alive, I have a certain temperature range within which I operate, then if you just look at me through the eyes of a physiologist or a psychologist or an economist, however you look at me, you will think to yourself, oh, that thing seems to be behaving in a way that's keeping its temperature between this particular range. So it'll look as if it's trying to minimize the prediction error, as if I predicted I had this kind of temperature. So viewed like that, it's not surprising. Perhaps what is more surprising, well, it's not surprising really, but it certainly raises the question of different kinds of things. So it is almost, I say, tautological to apply the free energy principle to anything. and tongue-in-cheek, thereby it becomes a theory of everything. But it's not a theory of everything, it's just a theory of everything. Um, so,
Hmm.
so as such, it sounds as if it's um, too non-specific, too generic, too general, doesn't really have a purpose. But that's not quite true, because you can have different kinds of things that show different kinds of behaviors. Um, and the advantage or the application of the free energy principle um, is exactly what we were talking about before, in that it equips you with a way of modeling things, creating things, simulating things, understanding things. So if you knew something's generative model, then what you can do is effectively emulate or simulate or reproduce all of its dynamics on the inside. So if it was you, it would be your brain, and also its behavior. Everything that you said, and every way that you moved could, in principle, be simulated simply by integrating differential equations, writing down the generative model, and then working out how you would change, how all of your internal and active states would change in order to flow downhill on this surprise or this free energy functional. So that's the gift of the free energy principle in and of itself. It's a bit like natural selection. It's very pretty, but it doesn't actually do anything for you other than say, "Oh, that's a nice idea." But what you can actually do once you've got this mathematically naturalized understanding of existence of things or thingness, you can start to now model and simulate evolution, or in this instance, the basic mechanics that attends the kind of artifacts or systems that you might be interested in modeling. And I repeat, they could range from a thermostat through to a laboratory rat, through to an economic thing. If you can write down the generative model, then there is a maths at hand, and there is actually software at hand in order for you to be able to start to model and create and simulate these things.
I wanted to ask what life means in this context. Is life and biological systems, are they meaningfully different? Because you mentioned generative models, like I have a generative model, but does a rock have a generative model? Kind of interested, like you can say you can write down what mine would be, but can you write that down for everything that exists?
Again, it's another very leading question, which I suspect you know the answer to.
Like, sort of, you know.
Before I try and answer that, just to say, uh, it's going to be most of my day job as a theoretical neurobiologist and expert in brain imaging is actually trying to work out what your generative model is. Indeed, my generative model is. It's a very difficult task. So it is not simple to actually identify the generative model that provides an apt account of any person or any phenotype or any type
Right.
of artifact.
So can I just ask about that? So in theory, the free energy principle says if we found the generative model, we would know like all these things about what you would do, but that mathematically is just very hard to actually get to.
Yes, it is. It's not impossible,
Right.
and of course, many people, certainly in my world, empirically, neuroscience, for example, is exactly this endeavor, trying to impute or trying to identify the generative models, the world models at certain levels of coarse graining that account for behavior. You could regard the whole of psychology in this. I would also imagine that in other fields you find exactly the same. People trying to get good models of economic systems, for example. By trying to effectively write down the principles that underwrite the behavior of systems, and implicitly or explicitly, what you're normally doing is trying to reverse engineer on the basis of how something behaves on the outside, what you can measure of something, to get at what's going on the inside. So that is psychology in my world. But perhaps we should just deal with your, I think, more astute question. which actually speaks to this notion that there are different kinds of things. So what's the difference between a rock? Does a rock have a psychology? Does a virus have a psychology? Do you have a psychology? I would guess that you do, but it would only be a guess because I'm not you. But I guess you're sufficiently like me that you probably do have the same kind of generative model that I have, which is a very particular kind of thing. So just, the answer to those questions probably much simpler than you might imagine. So what, once you have got a physics of self-organization that can be applied to different kinds of things, you can quite simply say, well, this is this kind of thing and that's that kind of thing. So, for example, a rock doesn't have active states. Does it have an internal model? Yes, it may have an internal model, but it would be of a very, very trivial sort, and you never know what it was because you can't. It's not acting. It's not reporting its beliefs or its predictions. But in one sense, the interior state of a rock, the state of the molecules, could be read as encoding the ambient temperature that the rock's surface is currently exposed to. So, in a sense, there is a synchrony, an informational synchrony between the inside and the outside of the rock that could be interpreted as a really, really simple generative model, just representing one state of the world, which is the temperature. And if I wanted to, confirm that, I'd have to actually break the rock to measure the temperature on the inside, which is part of the problem. You never really know. We only have to infer what's going on under the hood. In the same sense, you can imagine that a thermostat had a little generative model. It believes that its very, very monothematic, unidimensional sensing of the world, which is just one temperature variable, it believes that it lives in a universe that has this particular temperature, and thereby, if it can act upon the world, it doesn't need to know it's acting, then it will act in order to minimize the prediction error and just bring the temperature of the room back to where it thinks the temperature should be. So this is, I think, a very simple example of this sort of homeostasis read as a behavior of a thermostat that is just fulfilling the predictions of a thermostat. The thermostat predicts it will sense this particular temperature. So, and implicitly has a very, very simple generative model. So then you start to ask, well, what's the difference between me and the thermostat? Or what's the difference between you and the thermostat? The answer is, I think, quite simple. It's that, well, first of all, let's just see what we've just done. Is a thermostat alive? You probably say it wasn't. Is a virus alive? You might say it was. It certainly has a sort of biotic aspect to it. So biotic things generally have to have active states, and that doesn't mean that they have to move. But they have to move in a way that has a certain autonomy, a certain itinerancy, which means that the implicit generative models for the biotic or biological for life are not quite like a thermostat, because the generative model of the thermostat just has one fixed point. So its internal model, its world model, is just a fixed point. It's this temperature. What's governor would be another example. But something like a virus, or even simpler life biological artifacts, will have an autonomy where the fixed point moves around. So there's going to be autonomous dynamics as part of the generative model. It believes its world will change. And in virtue of that, it will behave and move in a continuous way. So it'll have active dynamics. It'll have autonomous dynamics that are revealed through its actual movement. So that would, for me, be life. Is that sufficient to describe me and you? I don't think so. What's the difference between something that just moves around? For example, a virus. And I think the difference would be that you and I plan. What does that mean? Well, it just means that our internal models, our generative models, are special in the sense that they now include my own action in the causes of my sensation. So remember before we were interpreting minimizing free energy in terms of belief updating, but beliefs about what? Well, beliefs about the outside that is causing the sensory impressions on my sensory epithelia or the surface of the rock, for example. So that those causes are hidden behind my sensory veil, the sensory states that say the brain has access to, or more generally the internal states of anything has access to. So the difference between you and me would be the difference between you and me and relative to a virus would be that we now treat our own actions as one of these causes that are hidden behind our sensory veil. So technically, in machine learning and artificial intelligence research, these would be referred to as latent states or hidden states. They're states that are part of a generative model that are fictive and hidden behind your sensations, your sensory data. But if I now include my own action in these unknown random variables or hidden states, I now have a very peculiar setup. I am now something that can act upon the world, and everything that my actions do is in the service of minimizing prediction error or free energy. But I don't know what I'm doing. I can only infer what I am doing by the consequences, by the sensory consequences of my action. So now my beliefs about action now become divorced from my actual action, unlike a thermostat. The thermostat will actually know whether it's switching up, the heating element on or off. But in big things like me and you, we don't have direct access to our own actions. We can only sense the consequences. So see where we've got now in terms of these very special kinds of things, where we now have a world model or a generative model that includes the consequences of my own action. And of course, the consequences haven't yet been realized. These are random variables in the future about which I have to have beliefs, which means that I can now treat my approach to action, my sentient behavior, as a belief updating process about what I am going to do. And this is known as planning as inference. And I use that phrase because the simple distinction between you and the virus is that you plan and the virus doesn't. So, I've sketched out a sort of taxonomy of different things, some of which are alive and some of which are not. And within those things that are alive, there's a key distinction between those things that plan and those things that don't plan. There will be other distinctions, of course. We could start to argue about, do I know I'm a thing? Am I aware that I am a thing? I could plan without necessarily knowing that it's me doing the planning. But then we're getting more into philosophy than psychology.
Sometimes I'm, in a way, kind of scared and daunted by how simple the free energy principle is in how it explains the world. So what would you say it says about free will and determinism and agency? Like you mentioned there, planning seems to make things a bit more complicated because now suddenly our action and perception is like there's some disconnect and we're needing to make more longer term models and predictions. But yeah, anyway.
Yeah, but I think that's a very important observation. The notion of making longer term predictions is quite crucial because that equips your generative model with a temporal depth which most artifacts don't have. I mean, the moon doesn't have it, the weather doesn't have that temporal depth. Very small things don't have that temporal depth. Any given cell in your brain wouldn't have that temporal depth. But at a certain scale and a certain size of things, then you do find these quite remarkable world models, or things look as if they are behaving under a remarkable world model or generative model that can look quite deep into the future. Deciding which university to go to, if you're a physiologist, you're now in a position of being able to suspend your homeostasis and engage what some people refer to as allostasis. So this is the notion that instead of, for example, if I was feeling cold, I could engage without any planning all the reflexive actions that would minimize the prediction error induced by thermoreceptors registering a surprising temperature. And I could start shivering, I could engage pyrorexin, and my hairs might stand on end. I could divert the blood from my skin into the internal organs. I could reflexively, in the moment, do the kinds of things that are going to attenuate that thermoreceptive prediction error. But if I can plan, then as soon as I start to feel cold, I can just go indoors, put a coat on, or put the radiator on. Now, notice what in doing that, because I've been able to plan into the future, I now do not have to engage my shivering and my sort of autonomic responses to being an extremist. So I have eluded those surprising states that would normally induce a homeostatic response and become much more allostatic. So this is a much more, if you like, sophisticated, more complicated way of maintaining my characteristic states, which allow me to suspend a homeostatic reflexive response simply because I got this deep temporal depth to my generative models that usually comes hand in hand with having a hierarchical or a deep generative model. So I think this notion of looking far into the future is quite crucial, and it really does distinguish perhaps you could say that there are different kinds of sentient behavior and the kind of behavior that comes along with the ability to plan. I think is qualitatively quite different. It lends us a temporal thickness to what's going on. You were trying to persuade me to talk about free will, which
Yes.
which I don't know if I should. That's a bit too much like philosophy, and you're always in danger of upsetting somebody when you wax lyrical as somebody with no formal training in philosophy about free will. I'll say very briefly that in virtue of this autonomy that we talked about, that is characteristic of biological systems, then mathematically, I think you're quite licensed to talk about free will if free will is just the fact that it is self-determined. There are people who argue that's not good enough. There are people who argue it has to be, free will has to encompass counterfactual other ways of doing things. So you have to have a choice, as it were, that you could have done this, or this, or this, but you actually did that, or that you will do that. So free will, thus defined, again, in a very philosophically naive way, would, I think, only be found in creatures that plan, or systems that plan, quite simply because the planning is actually, or depends upon, rolling out into the future a counterfactual future that has not yet happened, and then you select the particular plan of action or narrative or policy that has the least expected free energy or the least expected surprises. There's a lovely story about what that would look like and what that means. But for the moment, I think the key thing is that you do have a notion of selecting amongst counterfactual futures if you have the kind of generative model that can actually roll out into the future. And of course, we've just said that that's a special kind of generative model, and it's only that kind of model. You'll only find that kind of model in systems that can plan, and they have this sort of special but relatively simple aspect that they represent their own actions as latent causes of their sensations.
You've talked there about planning and being able to have generative models, but also to look at our models and our plans and select the best course of action. So I'm wondering if the free energy principle says anything about our experience of consciousness or self-consciousness, the experience and what these mean in via thinking in these terms.
Right, you really don't want to do philosophy, don't you?
I was talking to a philosopher yesterday, so maybe it's in my mind.
Right. So yeah, I'm not a philosopher, but I got lots of friends who are excellent philosophers. So I apologise for the naivety of the answers, just in case any of them are ever watching this. So, first of all, the free energy principle is not a theory of consciousness, and and so you would have to work quite hard to apply the free energy to questions of consciousness. People do that, and they do it in many different ways. Um, and I will list a couple of them, but with apologies to the approaches which that I'm omitting here. So the first thing that you could bring to the table is that to be conscious, you have to be an agent. So you have to be active. You have to have in mind agency, and of course, in order to have agency, you have to have the ability to plan as an agent. So we come exactly back to what we were saying before, that there are certain natural kinds that have generative models that look into the future and can plan. At the same time, they become agents, and I think that will now become a necessary condition for consciousness. Is that in and of itself sufficient to explain selfhood? I think not. I think that the answer would lie not in the free energy principle, but the generative model to which you would apply the free energy principle. So I think what you're talking about now is a more sophisticated kind of generative model that has a metacognitive aspect, that has a hierarchical depth now, that looks at its own machinations and can act upon its own belief updating, and specifically will entertain hypotheses as part of its generative model that can be read in the following way: that I can be in this state or this state or this state, and I have to recognize what kind of state I am in. So I could be in this context, I could be an interviewee doing a podcast. I could, in another context, be doing the gardening. I could be very embarrassed. I could be very frightened. I could be in love. All of these different states of being are now recognizable hypotheses that contextualize the kinds of things I predict myself to do, and indeed, under the free energy principle, or active inference as we call it, then I will do those things in a way that is contextualized appropriately. But look at what we've just said, though. We've now got a generative model that represents beliefs of the sort, I am in this state. And just by saying that, then you now have equipped this generative model with a certain kind of selfhood, because it's I, and it's me doing things. It's me as an agent. I am embarrassed in this discourse. I am about to do this mowing of the lawn when I am a gardener. It's all about me as an agent. So if I can recognize that I am an agent, and I can have a sufficiently fine-grained model of the different kinds of agency that I would deploy in this context, then I will now have that kind of hierarchical depth, I think, that could indeed support, would be necessary for consciousness of the sort that I recognize I am. Whether I would be able to talk about it propositionally is another question. You might need another level on top of that, and some people indeed argue that you should. But certainly, it would there would be a minimal selfhood there, and it would be evident both in terms of my overt actions, because I'm now predicting myself to behave in a context-sensitive or specific fashion, and you will be able to see that in me. But also I will have internal actions, covert actions. I will be attending to different things. I will be selecting different kinds of prior beliefs that are appropriate or fit for purpose for this particular context, or the way that I'm currently feeling, if these were valenced or emotional inferences about myself. So perhaps a simple example of that would just be, how can I feel frightened? How can, if I can be frightened, what does that mean about how expressive my generative model is? And why would I ever want to have that kind of expressive model? Well, if I had the hypothesis that I am something and that I am frightened, then that would explain and thereby provide apt predictions and thereby minimize surprise or free energy certain situations, for example, where my vision was reporting it was dark and there are lots of shadows I cannot identify. Um, Other kinds of signals were reporting a racing heart. Other signals would be reporting um, a certain muscular rigidity. All the sort of interoceptive, proprioceptive, and exteroceptive signals that one would normally associate with being in a state of fright and flight, or being in fear. And of course, I am at the moment, at the same time that I am recognizing this constellation of sensory inputs that now I can make sense of with this one simple hypothesis. Oh, I am a thing and I am frightened. And of course, in so doing, I now have predictions about how I will be behaving both autonomically and attending internally, and motorically in terms of a fright and flight kind of motor preparation. And I am now going to be causing the very signals I'm trying to explain. So again, we come back to this wonderful circular causality that we're making sense of signals, but we are actually deciding and planning which signals to actually solicit and attend to, and to go and sample. So that, I think, would be a minimal requirement to start to get even a minimal selfhood out of a generative model. Would that allow you to talk about philosophy and quality of experience and qualia? Probably not. You probably have to go to another level on top of that.
Yeah, it's interesting because as you talk about the self and self-consciousness as kind of constellating together almost many different generative models or many different situations and possible sub-identities. You can be gardening in one moment, doing a podcast the next. So it's interesting that as you get more hierarchical like that, you kind of, by necessity, the sphere energy principle becomes more and more, I don't know, not complex, it's the same principles, but it's almost many different instances sort of together. So
yes, no, I think that was very well expressed. Yeah, so the free energy principle doesn't change, but the generative model to which you apply it can become very, very complicated. And then we come back to the difficult problem of me inferring your psychology and reverse engineering that very complicated generative model. Absolutely, yeah.
I wanted to switch tracks a bit and talk about neuroscience, more specifically. How do we learn about the brain? What recent developments have there been in neuroscience? And how do we think about the techniques that we have to understand the brain, given that it's so complicated and we can kind of, we have a limited ability to sort of look at it and zoom in on exactly what it's doing?
Yes. I mean, that limited ability, I think it's worth just sort of reflecting upon why we have that limited ability. I think there's something quite fundamental here. We haven't mentioned the Markov blanket construct, which actually underwrites the free energy principle, where the Markov blanket is something that separates anything from everything else. And so when I was talking about sort of internal states and active states and sensory states, I was implicitly in my head referring to this Markov blanket that comprises the interface, the inputs and outputs of a particular system that has internal states, that has a two-way exchange with the rest of the universe, which can be the external states, and that two-way exchange being mediated by these sensory and active states that together form this blanket. They form a way of separating the thing from everything else, and this is at the heart of the theory of every space thing interpretation of the free energy principle. Just realizing that tells you immediately that you can never get direct access to the internal states of anything, which means that you can have all these grand theories about Bayesian mechanics and self-evidencing, which is another way of describing this Bayesian mechanics, or evidence maximizing, surprise minimizing kind of dynamics. But you'll never know, because to know, you'd have to break the Markov blanket to look underneath, behind the skull, as it were, behind the sensory veil. And of course, in so doing, you destroy the Markov blanket and you just destroy the thing in question. So there's a fundamental reason why understanding the generative model that something else uses is a very difficult game. You can only infer it on the basis of what you can see going on. So, yeah, certainly neuroscience is a prime example of that. But I'm sure in your own field, if you can't get into the system, if you're not part of the system in and of itself, all you can do is infer how it is working from the outside. So I'll never know whether you're conscious. Because to truly find out, I'd have to be part of your internal states, and to do that, I'd have to break both of our Markov blankets, and we would cease to exist as defined by
That'd be
the.
awful.
So if you pursue that line, then that tells you immediately what kinds of neuroscience tools that people rely on, and where the great advances recently have been evident. First of all, if it's the case that you always have to either infer and reverse engineer on the basis of what you see something doing, then you're talking about psychology. You're talking about possibly even a behaviorist kind of psychology, but I think once you put the sort of cognitive neuroscience into the mix, you're getting much closer to inferring the kind of world models people use in their heads. And that just is psychology, and there's a vast history of psychology that underwrites neuroscience generally. And interestingly, you sometimes get nature's experiments where you do actually get a breach of the Markov blanket and you do get a lesion to the brain. And then you're talking now about the vast literature that attends neuropsychology, the lesion deficit model. So if I now want to understand the structure of your generative model, then I need to understand your neuroanatomy and your message passing and belief updating, the dynamics on that structural anatomy, that computational anatomy. To get an insight into its broad brush or macroscopic structure or anatomy, I can actually use brain lesions. For example, in World War I, people were very carefully looking at the deficits, both cognitive and say visual, and in terms of word production, following damage to the brain, due to people getting shot in the head or people having strokes, for example. So there's an enormous literature making the best use of the data from very sad cases due to brain lesions. So nature has done the breaching of the Markov blanket for you. The other way to do it, of course, is to wait until the brain is dead and then you dissect it. And then you can breach Markov blankets by cutting it and doing lots of neuroanatomy at different scales. So there's a vast history of these kinds of literally intervening on the Markov blanket, or interventions, or reverse engineering inference about the underlying anatomy that's centuries old, if not millennia. So how would you, in that light, would you see recent advances? And I think that the sort of key recent advances that we've seen in neuroscience really rest upon being able to peer behind the Markov blanket, or in a way render it more transparent. And that's, of course, brain imaging. So being able to look at the brain in action using modern brain imaging techniques. Or certainly, I repeat, you're never actually breaking the Markov blanket, but you can get at other observables on its surface which were hitherto hidden, very much like a scientist would use, or an astronomer would use a telescope, or a microbiologist would use a microscope. You can enhance the amount of observables that make your inferences about the internal structure and dynamics of the brain more informed and more precise. And brain imaging, I think, is one of the key things there. There are lots of other developments that would not fall under the rubric of brain imaging, but in a sense, they just realize the potential of imaging in its most general sense. So things like optogenetics, so being able to now prepare brain tissue in a way that generates particular signals that you can then pick up with brain imaging and other recording devices, making them much more specific, say, to particular cell types or particular the use of particular chemicals to transmit signals. So it's all about measuring the brain in action, and on the basis of those measurements, trying to infer its underlying functional architecture. And I could wax lyrical about the principles that are emerged from that.
When you talk about lesions or damage to the brain and how that helps us learn about it, how should I think about that in terms of Markov blankets and the free energy principle? Like, if you see only part of the brain working, does that help make inferences about the whole model? I mean, does not what it is change when there's damage?
Yeah, again, that's an excellent question, and in fact, exactly leads into what I was wondering if you wanted me to talk about. Yes, you
Okay.
can. So, first of all, perhaps we should just back up a bit and just look at one of the where things like the free energy principle, or where the free energy principle specifically, what it inherits from it. It has many sort of paths of legacy. You could tell the free energy principle story from Helmholtz, or you could from Richard Gregory, the perception as hypothesis testing. You could tell it from perceptual control theory. A lot of people like to tell it from the perspective of cybernetics. So the turn of the last century, in the first quarter of the last century or half, the cybernetics movement brought a lot of key principles that are still in play and implicit in the free energy principle. For example, one key one is the notion of any controlling device, such as the brain, has to be a good model of the world that it controls. So this is known as the good regulator theorem, with attendant principles or laws, such as the law of requisite variety, for example. The degrees of freedom of the brain has to match the degrees of freedom of the world that is being navigated, controlled, or explored. What that tells you is that the brain must distill or have installed in it the same kind of anatomy that the causal structure of this world has. So that tells you immediately you're looking for certain anatomical characteristics, brain structures, that can be guessed or can be inferred from the very structure of the universe that we navigate. So there are some wonderful examples. First of all, the fact that in our universe, we make sense of it in terms of, say, scene construction, that it is composed of different objects that can be in different places. It doesn't have to be like that, but it looks as if our universe can be easily explained, modelled, by being composed of lots of different things in lots of different places. And if I move something, it doesn't change what it is, it just changes where it is. Now that's interesting, because that tells you that there's a very, very profound, foundational statistical independence between what something is and where it is. So if I tell you what something is, you don't know where it is. And if I tell you where something is, you don't know what it is. So that knowing one doesn't tell you the other. Now, what does that mean? Well, it means that if I have a generative model that distills and installs that conditional dependence into the belief updating and the message passing, I'd expect to see two separate parts of my anatomy, two separate parts of my brain, dealing with the whatness and the whereness of my visual input, trying to provide explanations of what I'm actually seeing by combining together predictions about what I'm seeing and where I'm seeing it. And that's exactly what we see in the brain, that we get this sort of factorization, or the factorization of the probabilistic causal structure of the universe is now translated into an anatomical modularization or factorization, and a distinction in terms of, to use Leslie Angelider's characterization, what and where streams in the brain. So there's, from the visual part of the brain, there is a ventral what stream, by ventral I mean sort of lower down, and then a dorsal or along the top of your head, where stream, that directly recapitulates this fundamental statistical causal architecture of the world in exact accord with the good regulator theorem. And you can generalize that argument to any modular architecture that picks out certain conditional independencies, technically factors in a mean field approximation or a mean field assumption about the causal structure of the world of the kind that physicists would use, and you get to principles of functional specialization, segregation, and you can identify this part of the brain is concerned with visual motion, this part of the brain does this, and this part of the brain does that. And by doing it just means it is generating predictions of the attributes that it is specialized to predict. It is a model of that particular latent state or latent factor. We've just talked about deep generative models, and you were sort of marveling how complicated they can be. So what do you mean by deep? Well, you mean that it has a hierarchical depth. What is a hierarchy? Well, actually, interestingly, it's actually defined by conditional independences and Markov blankets, which separate different levels of the hierarchy. But from the point of view of this conversation, what we're saying is we'd expect to find hierarchical structure in the brain, anatomical hierarchies in the brain, simply because we live in a deeply structured semi-Markovian, non-Markovian world. And we know we do because our world is actually populated with things like you, which are very sophisticated and very deep. So we know that we will be looking for anatomical and physiological evidence for hierarchies in the brain. And of course, that's exactly what you find. So those are two sort of coarse-grained examples about how you can start to infer and understand functional anatomy, computational anatomy in the brain from a purely theoretical perspective, and then go and get brain imaging evidence to confirm your hypothesis that, yes, I have this kind of functional specialization, and I have a hierarchical organization, and I have certain parts dedicated to planning, and so on and so forth.
Yeah, it's fascinating that based on the complexity and hierarchical nature of the world, we should expect that the brain would be specialized in certain regions, or should have one part of the brain looks at what and another where, and then we do find it. Maybe I could then bring that back to my question about, say you have a brain lesion or damage. I'm even interested in split brain patients and the work of Ian McGilchrist. What happens when there's then damage to certain areas?
Right. Yes, I should have brought that issue to closure. So if you have this principle that if there is I repeat, technically a mean field approximation or a carving up of the causes of your sensorium in terms of independent factors, then you'd expect this to be represented in a similar carving up and modularization of your anatomy, and that if you lesioned a particular module or brain area or factor, then you would lose the capacity to infer, represent in some sense, or predict that particular attribute. So, for example, if you had an impairment to that part of the visual cortex that we think is responsible for inferring and predicting visual motion, area V5, which is around here, then you might say that you would have a selective loss of the ability to detect moving objects. And it may or may not be the sort of bilateral, depending upon the interhemispheric and the representation or sampling of the different hemispheres lower down in the visual hierarchy. So that would be a nice example of looking for convergent evidence from brain lesion studies, because what you'd be hoping to see, and indeed what people did see, and I chose that example deliberately because the first convergent evidence for this kind of functional specialization only really came out in the very early 90s. It may sound quite surprising that this fundamental principle of functional specialization was only a hypothesis prior to this on the basis of lesion studies, but was only confirmed with brain imaging. So what people, I'm thinking here specifically people like Professor Semizeki, hypothesized was that on the basis of local lesions to this motion sensitive area, he hypothesized that this area would be functionally specialized for visual motion, and then was for the first time able to confirm that with positron emission tomography or brain imaging that predated just by a few years functional magnetic resonance imaging, which you should know about being from Nottingham.
Should I?
Yeah, well, the MRI was invented at your
Okay. Oh.
university. Yeah.
Oh, awesome.
Yes, yes. I think the gentleman got a Nobel Prize for it. You can probably find some plaque on the university site celebrating that. So that was already relevant for this particular argument. The point being that this one could actually see on the brain images that this particular motion sensitive area that was specialized for visual motion responded to stimuli that had motion in it relative to stimuli that didn't, and uniquely so. That's the key point, that it was specialized in the sense that it activated and everywhere else didn't. So that you've got this local function, so that the specialization was segregated in this particular little part of the brain. Hence the principle of functional segregation, which is one step further than the principle of functional specialization. So I think that's a beautiful example of brain imaging endorsing the kinds of hypotheses that would come from neuropsychology, the lesion deficit model. And then since that time, year by year, people have got more refined and more encompassing in their understanding of this kind of functional specialization. And then the complementary principle, which is the principle of functional integration. How do you do your belief updating? How do you pass messages and impose constraints on your belief updating among different levels, or indeed exchange messages between functionally specialized areas, usually by converging upon lower levels or diverging on lower levels. So then you get into the game of the connectivity that underwrites the causal links, the statistical associations that are being installed into your brain through experience-dependent plasticity, and many different sort of timescales.
You've collaborated on a paper on hallucinations, and when we have imagery in our brain that's not necessarily based on perception, whether that might be dreams or on like drugs or maybe brain damage or sickness and illness. So would you be able to speak about what hallucinations are in the free energy principle framework?
Yes, and again, that's an excellent question. It might be useful just to drill very briefly a little bit further on the predictive coding way of understanding free energy minimization. And I think that's a useful vehicle, and certainly predictive coding as a scheme that could be used to enact or to realize the imperatives prescribed by the free energy principle is a very useful and plausible metaphor for early visual processing. So the idea is that you are cascading down these visual hierarchies that can be conceptualized in terms of a centripetal hierarchy with a deep center, generating predictions towards the outside, towards the sensory epithelia, some of which may be visual, some of which may be auditory, some of which may be interoceptive, but generating predictions down at each level, each hierarchical level, evaluating the quality of those predictions by comparing it with what it was trying to predict to form a prediction error, and then sending the predictions back up again. So you've got this notion of outward flowing predictions and inward flowing prediction errors. So the prediction errors are literally updating your beliefs. They're driving neuronal populations in order to best infer or represent the causes of your sensations. And we know that they are the best because they are continually trying to eliminate the prediction error that they've actually generated. So that raises the interesting question: which prediction errors do I attend to? Which ones do I equip with a selected, or which ones do I select to privilege them in terms of updating me? If I've got this vast array of prediction errors impinging upon me deep in some hierarchy, which ones do I pay attention to? It's very much like, which news channel do you choose, which social media, and what you want to do is avoid the fake news. You want to avoid imprecise channels of information. So what you have to do is to estimate the precision, the reliability of these prediction errors or these surprise signals, the newsworthy information. So, when I watch the news, I am looking for stuff that surprises me. I'm not looking for stuff that I can predict. It's the newsworthy information that is the prediction error, and it is this that changes my mind. But I have to be careful in evaluating the quality of that prediction error or its precision. So what that means is I have to have a whole other part of my generative model that is predicting the precision. And in so doing, I can now select among various prediction errors to give them privileged access to belief updating at a higher level. So on that point of view, of under that kind of model, which some people refer to as sort of precision engineered predictive coding, or the minimization of precision weighted prediction errors. You find that quite a lot in the predictive processing literature. If you're in engineering, this would be getting the Kalman gain right. If you were, I'm not sure what it would be in economics, but I'm sure you can tell me. But there will be a measure of uncertainty. So precision is the inverse of uncertainty. So there will be a measure of uncertainty, and you have to estimate the uncertainty in order to properly balance different sources of information, or indeed the sensory evidence against your prior beliefs when cast in terms of Bayesian things. So when that goes wrong, you have a very nice explanation for lots of very horrible things. So, for example, you can cast a lot of psychopathology as broken or false inference that's due to a failure to estimate the precision. If you remember your 101 psychology or statistics, this is the standard error. So it's like doing an analysis of variance or evaluating a t-statistic where you can't estimate the standard error anymore. And of course, as soon as that happens, that you are exposed to both type 1 and type 2 errors. You can infer things are there when they're not, hallucinations and delusions, or you can infer things are not there when they are, neglect syndromes, dissociative syndromes, what used to be called hysterical syndromes. So a vast array of false inference now offers itself as an explanation for things like hallucinations, and to a certain extent illusions. But illusions are, I think, sort of Bayes optimal. It's just that there's a difference between how you explain this pattern of sensory input and how it's actually generated by a cheeky experimenter who's perversely done it in a different kind of way to see if he can get access to your prior beliefs. But from your point of view, an illusion is a perfectly Bayes optimal normative kind of inference, but hallucinations are not. And this means that you can intervene on this aspect of predictive processing or free energy minimization, where this aspect specifically is setting the gain or the precision of prediction errors pharmacologically. And then you can get a good story about psychedelics, that if I can somehow change the balance between what a priori you think you are seeing in terms of representing certain objects, say a face. A face is an apt explanation for this pattern of sensory input, and I can increase the precision of this until it effectively ignores by suppressing the precision of ascending predictor. So I don't change my mind. Even if I'm looking at a house, if I can increase the relative precision of my prior belief relative to the sensory evidence, I can still perceive a face. But now if I give a drug that blocks the excitability of the neurons that are reporting, or the brain cells that are reporting prediction errors and maintaining this very precise prior belief, then I now render myself much more sensitive to all different kinds of interpretations with the same sensory input. And that would be maybe one explanation for the psychedelic experience, that you're now attending to the sensorium, you see things and patterns, faces and houses together, spirals, whatever, possibly at a sort of lower level of abstraction, a more elemental way of sense making, this particular pattern. So again, just understanding the computational architecture of the generative model gives you a really nice access, a way of describing sense making as perceptual inference under that model that can offer explanations for ways in which it could go wrong, or ways in which it can be sometimes very usefully perturbed by psychomimetic or psychedelic drugs, or repaired using psychoactive, the kind of drugs that you use in psychiatry.
Am I right in saying it's about your perception? You might be getting the same perceptual signals, but your models, you like, for example, you say psychedelic drugs, you could impose your model onto the world to like a great degree, so that you really try and match what you a priori think you see to what is there, and then that sort of morphs what you kind of experience. Is
Yes.
that kind of right? Okay.
No, absolutely. Yeah. I mean, you must have had the experience, when the light is dim and your visual impressions are very imprecise, then you suddenly start to see faces and shapes and things that you perceive as fully formed concepts or percepts. The interesting question is, sometimes you know that they're not actually there, and then you have to ask yourself, how does your brain know that what you're perceiving is not actually there? And it may well be that the answer to that is, if you know the strength of your predictions of precision, you can actually have, again, a sort of hierarchy, deeper metacognitive aspect on whether you're actually seeing this, whether you're not seeing this. And this brings us into the fascinating but sometimes vexed world of phenomenology, and whether something is phenomenally transparent or opaque. Am I looking at am I seeing something, or do I know that I am am I experiencing it directly in a transparent way, or do I know I'm looking at it? That's a remarkable capacity of things like you and me, which I imagine, say, a bee wouldn't have that capacity.
You mentioned that hallucinations can, or they might be adaptive. I mean, they're part of the way we see the world, right? So sometimes it's going to be adaptive, and sometimes not. But I think about dreams, for example, and or sometimes we might actively want to get into psychedelic or drug-like states. So, what are the adaptive benefits of hallucinations?
Right. I mean, you could argue, and some people do, that all perception is basically constrained hallucination. It's just that again, I think right in the very first response to the first question, I used the word, the brain is a fantastic organ, and I was trying to impart the notion that our percepts are the results of fantasies and guesses and hypotheses that are either confirmed or disconfirmed. So, I could have used the word hallucination, that everything that we perceive is, at one point, an hallucination that's just basically entrained, either very, very precisely or very, very imprecisely, depending upon this precision control, by my sensations. So you could argue that everything is a fantasy, and everything is hallucinatory in one sense. What are the benefits of that? They are manifold. So you mentioned implicitly two. One is the kind of hallucinations we experience during sleep. The second is putting ourselves in certain states, whether it's meditative states or mindfulness states, or whether it's assisted with 5-HT2 agonists such as psilocybin or LSD, sort of assisted psychotherapy for being one example of these. All of these different ways of accessing different brain states have I think the agenda to relax your prior beliefs, either by volitionally focusing on the sensorium, say focusing on my breathing, or neurochemically by suppressing the precision of very deeply held prior beliefs. Why might you want to do that? Well, there are two reasons you might want to do that. The first is to become skilled in getting volitional control over this assignment or affording precision to different sensory inputs. So not usually a lot of this machinery is not under volitional control. My favorite example would be saccadic eye movements. When we move our eyes, we actually attenuate the precision of the visual prediction errors. So we can't actually see the optic flow induced by our own eye movements, and we don't want to. But we don't have any volitional control. No matter how hard you try, you cannot see the visual flow induced whilst you're actually moving your eyes. But in principle, there are certain kinds of these subpersonal sensory attenuation or selective attention mechanisms that could be mentalized and brought under volitional control if you become very skilled as a meditator. So that empowers you now to start getting control over attention to various sources of evidence about your body or about your person, wherever sphere you're trying to update your beliefs within. So that's one thing. The other thing, which is very very common therapeutic target and expressed in a very commonsensical way, is that some people get very, very precise priors and get stuck in a rut. So, for example, they have agoraphobia or obsessional compulsive disorder, or the kind of depressed psychomotor poverty that just locks you in and stops you exploring the world and gathering evidence for the fact that you may not be necessarily depressed. So this involves basically broadening the latitude, broadening the landscape of potential prior beliefs about the sort of thing you are and the way that you behave and engage with the world, and that often pro-social world in terms of dynamic interactions and social interactions with other people. So suspending very precise prior beliefs that are not fit for purpose at this point in your life, in this context, can actually be therapeutically very empowering, provided you can find a better prior belief or explore alternative hypotheses about your engagement with the world.
Can I just explore and see if I understand when you mentioned depression? It's interesting because you said that someone might not go and explore alternative hypotheses that they aren't depressed. So would you have to speak about the free energy principle and predictive processing, and like how we can change the world or we can change our beliefs? That sounds kind of paradoxical, right? Like we would maybe remain in a depressed state because that kind of satisfies what we already predict and believe. Am I right in saying that?
No, absolutely, and I think it's an important observation that there are certain homeostatic and adaptive aspects to most pathologies. So depression may indeed be one, in the sense that if I'm in if I find myself in an adverse situation where I am potentially going to be upset or damaged by interactions with other people, then by being depressed and withdrawing, I will protect myself against such adversarial damage or interactions. If, for example, I have a stress response in a situation that does actually require me to be more vigilant and to possibly escape from that situation or to freeze so that I am not noticed, that's very, very functional. What the problem is when that response and that inference about the kind of state that I am currently in is no longer fit for purpose because the world has changed, but your particular strategy prevents you from recognizing that. So I think that's the vicious trap. And of course, what then happens is that things like depression and stress become chronic. They become enduring, and then they become pathological. So being miserable and being depressed in a reactive way is perfectly functional, and because you wouldn't have depression if it wasn't subject to that kind of positive evolutionary selection pressure. But when it sort of endures longer than is appropriate for the changing world, then it becomes a pathology, and then you go to the doctor, or you don't go to the doctor because you're depressed. But notice what the mechanism of that endurance is. You actually said it, and I think it's very important just to reiterate it. It's the fact that this particular adaptive response to a change in circumstance, a surprising situation, is the response that prevents you getting evidence that the situation has changed. So locking yourself indoors, not answering the phone, withdrawing from social media, all of these things are exactly preclude you from getting evidence that in fact people have changed. People do actually like you, or this world is not quite so adversarial out there. But you will never know that because you've denied yourself the evidence to change your mind. So this is exactly the stuck in the rut situation I was referring to before, that you may need help exploring other hypotheses. Oh, it's not damaging to engage with other people, or to start going out, or to look at my social media in exactly the same way that if you had a phobia, say of bees, so you believe you're going to die of a heart attack if a bee stings you. So you're going to spend your entire life avoiding bees. So you'll never be able to test the hypothesis, well, not necessarily false, but the unlikely hypothesis that being stung results in fatality. So it's a kind of behavior that is self-maintaining. It's autopoietic in one sense. So that's when you can get trapped in these local minima, and that's when you probably need some therapeutic intervention or assisted psychotherapy or exposure therapy in order to start to explore other ways of being and relax those very precise prime beliefs about the kind of thing that you are and the way that you engage with the world.
We talked about hallucinations, and this might be related. Dreams. Do you have any insights on dreams and what they might be doing, and to what degree they're adaptive?
Yeah, so you mentioned that before. Absolutely. There's a slightly different story, a different story to be told about dreams, and it's the kind of story you would also bring to the table to understand the importance of thinking about things, just introspection. Literally just closing your eyes and being thoughtful for a moment about how you explain your lived world. So dreaming is a really interesting situation in which your natural neuromodulators, your natural psychedelics, as it were, are switched off to the extent that you are now sequestering the brain from all of its sensory inputs, with the exception of the central nervous system, which is the eyes and the oculomotor system. So what that means is when you're asleep, there is no sensory information to make any sense of, with the exception of the eyes, which is why you have rapid eye movement during dreaming. So how can you minimize the free energy when there is no data to explain or to predict? And the answer to that, I think, is quite profound. It's a bit mathematical, but I think it's worthwhile just mentioning it, because it provides, I think, a really useful perspective on sleep, on introspection, on aha moments, on creativity. And that perspective is afforded by realizing that surprise is the same thing, or can always be written as complexity minus accuracy, whereby what I mean by complexity and accuracy is that the accuracy is the effectively how accurate your predictions are, which is one way of understanding the role of prediction errors as scoring the surprise. So the more accurate your predictions, the smaller your prediction errors. But there's also a complexity part of surprise, as described by the variational free energy. And that complexity scores the degree or the degrees of freedom you've had to use up in order to provide that accurate account. It literally scores the degree to which you change your mind in order to explain this pattern of sensory input or this bit of data. So if you want to minimize surprise, you want to maximize accuracy while minimizing complexity. What does minimizing complexity entail? It means finding the simplest explanation for some data possible. It's just Occam's principle. In the words of Einstein, keep everything as simple as possible, but no simpler. So there's a sweet spot that gives you an accurate explanation that is as simple or minimally complex as possible. So you can still, in the absence of data, so in the absence of any data, there is no accuracy. So surprise just is complexity. So if you want to minimize surprise while you're asleep, you minimize complexity. What does that mean? It just means removing redundant degrees of freedom from your generative model. It just means house cleaning, removing redundant synaptic connections. People like Julia Tononi would regard this as synaptic homeostasis from a biological point of view. It's basically minimizing the complexity of your world models by asking, could I have explained this particular dream more simply? And were these two associations in fact the same thing? So this is why I mentioned sort of aha moments and the creativity that comes from the insight that all of these different things are in fact examples of the same thing. And that just means basically pruning away exuberant, incidental synaptic connections, brain connections that are not necessary just to get at the underlying scaffold, the basic structure of your generative model. So in that sense, whenever you introspect, whenever you have an aha moment, you are basically suddenly seeing the wood from the trees. You're suddenly seeing the big picture, the simple picture, by identifying what is important and what was a distraction, and then literally getting a much simpler, more coherent, minimally complex explanation of what's going on. And that's a really important mechanism to minimize surprise or minimize free energy, to get these good generative models that will, from the point of view of sleep, mean that your model will generalize to tomorrow.
It's interesting because when you say complexity, it means like you don't want to change things that are really important. You don't want to just change things in the hierarchy that impact loads of other things, right? It's about parsimony. But that kind of makes me want to ask about important decisions, important events in our lives, whether that's sort of in our age or like rituals in our society. What's happening to us in our lives, or can we speak from your own experience, when we go through important experiences, or, we meet a loved one for the first time, or how at the birth of a new child, things like this?
It depends whether you're talking about life-changing experiences and life events, or whether you're talking about birthdays and Christmases and birthdays and Christmases and that daily, weekly, monthly, annual, possibly annual structure to our life. I think that's just part of cultural niche construction and keeping things as predictable and least surprising as possible. I got something to look forward to, and that resolves uncertainty, resolves the expected surprise, and that's all good. So that those kinds of events, I think, serve a sort of a different kind of purpose from the events of falling in love or getting married or choosing to go to this university or that university, or more tragically, the loss of a loved one. So these life-changing events are literally events that cause a change to your generative model of quite a profound sort. They may be actually quite structural. literally a change in the brain structure that you see, as part of normal aging and indeed in neurodegenerative disorders. So why would you have to change? Why would a life event induce a change in your brain and implicitly a change in your genetic model? Well, quite simply because your world has changed. Say you lost a loved one who you lived with. Your daily life, the things that you do and see and feel and hear, are profoundly changed the day after your loved one is no longer there. So you have to completely rebuild your genetic model, and it can take months, if not years, for that process, and could be read in terms of the distinct stages of grieving. For example, if it's a really profound life event, you can get resignation syndrome in certain people when they move country, and you will personally have experience of this. There is a kind of grief reaction which can be very full of pathos and sadness, but of course it doesn't have to be. It could be the kind of excitement and grief reaction you have when moving to a new city, for example, the exploration. So those life events are cause and consequence of the revision to the structure and parameters of your generative model that are requisite in order for you to maintain a good model of your lived world. And of course, they will entail a whole flurry and exuberance of prediction errors, driving all your belief updating. And what will not feel quite so pleasant is the inherent loss of certainty and the loss of precision. So you just don't know what you move to a new house. You don't know how to walk to the nearest shops or the bus stop, for example. That induces a certain degree of anxiety. You don't know what you're going to do. And you have to now respond to the sort of the epistemic affordances in order to resolve that anxiety, because it can take, days, months, weeks, years to fully do, depending upon the profundity of the life event in question. So these life-changing, life-forming events, I think have a very different role from looking forward to your birthday, which is a bit of reassurance in life.
And a quick follow-up on that would be with birthdays or Christmas, you talk about we have them repetitively and we know when they're coming. Do you think that's kind of on purpose, in that we like to know, we like to be able to predict when things are coming, and we like to have this kind of certainty?
Yes, I do, but I think it's slightly more subtle than that. What I think, I think that we like to know when we're going to be surprised to resolve that surprise. So it's not that we do things because they are boring. We do things because they have the promise of resolving and reducing surprise. So I think the birthday example is a perfect example. The very fact we have birthdays entails the receipt of presents. And of course, I am going to resolve my surprise by unwrapping my surprise present. That's the bit I look forward to. It may sound paradoxical that I've just said the free energy principle is all about minimizing surprise, and it is in the moment in terms of sense making. But if one applies the principle to the way that we actually behave and plan, then you get a very different picture. The picture you get is that you want to choose those actions that minimize your expected surprise in the future as a consequence of that action. Now, the expected surprise is uncertainty, which means that everything I do, and not what I sense, when I sense I'm going to minimize surprise, but everything I do will look as if I'm going to minimize expected surprise. So I'm going to look as if I'm going to minimize the uncertainty. So it'll look as if I'm very curious. So I'm going to search out those situations where I can resolve uncertainty that maximize information gain. What are they? It's watching the news at 10 in the evening. It's giving me, resolving my uncertainty about the state of affairs in the UK and internationally, for example. What am I going to do? I'm going to open my presents. And I know I'm going to open my Christmas presents as a child at a particular point in the day on Christmas Day, or if you're in Germany on Christmas Eve. So you know that you're going to you're going to minimize your you expect to resolve your surprise in advance, and that can be quite pleasurable. And again, it's the same kind of thing that you get behind the aha moment. You suddenly see a simple explanation, and suddenly you minimize your surprise by minimizing your complexity, but you can also anticipate that. So I think you touch on quite a key point, which we haven't really done before, which of course the free energy principle means that if you plan, then you will be a curious artifact. You will be a curious creature. You will be uh, um, either a scientist or a scientist in the spirit of the way that sort of artists explore and resolve their curiosity, or that we do it every day in terms of our interpersonal relationships, exploring because we're curious what would happen if I did that. And in so doing, we sate our desire to minimize our surprise because we're choosing to minimize our expected, or we're selecting those actions that minimize the expected surprise.
Can the free energy principle be applied to AI? And I assume it can, but to what degree is it useful to think about AI or large language models in terms of the free energy principle, prediction errors, and can it help us build them and understand them?
Yeah. Well, I mean, a lot of artificial intelligence, or certainly more generally, modeling um, um, and planning can be written down in a way that looks as if it is an instance of minimizing variational free energy. Indeed, things like variational autoencoders use exactly the variational free energy as their objective function to do their learning. So the same principles that underwrite biotic sense making and sentient behavior are exactly those principles that people use in machine learning and statistics and computational neuroscience. Um, um, the question about large language models is interesting because large language models lack a certain thing which render them quite trivial from the point of view of the free energy principle, is they don't act upon the world. They generate content, but they don't decide which content, which prompt. If they were able to choose which prompts they want to complete, then that would be active inference. That would be active sensing. That would be they would now become agents. But at the moment, large language models are not agents in the sense that we've been talking about them. So that they certainly can be, and indeed people are currently writing papers showing that transformer architectures are just um, a Bayesian inversion or a Bayesian formulation of highly nonlinear autoregressive models where the attention actually stands in exactly for what we were talking about, which is that precision weighting before, as estimated in a Bayes optimal fashion. So you can certainly cast large language models as an instance of a free energy minimizing artifact. But would you call them? Would they have the kind of intelligence that you have? And I would say, from the point of view of the free energy principle, no, they can't, because they don't act. They're like very expressive thermostats. No, they're even worse than that. I have to think about what they're like. They're very
Okay.
engaging,
Yeah, yeah.
very beautiful things. But from the point of view of free energy principle, there's no agency. And
Yeah.
one could argue there's no explicit um, um, understanding. But I think you'd have to just recall that I've just said that you can't look at behind the Markov blanket, but then of course you can when it's a large language model. You can actually get in there and look at the connection weights and the like.
You actually, is it surprising to you that something so simple, it's even hard to think about it in terms of the free energy principle and prediction errors, because you can look at it, it doesn't have agency. Yet, as you say, they're kind of beautiful and you can have lots of fun with them. And they for me, they ChatGPT and large language models can really help. So are they surprising to you? And what do you think about the fact that we have created something that, at least superficially, seems to gives so much despite its simplicity.
Yeah. Is it surprising? I'm not sure. I mean, certainly the public interest and the uptake and um, that portion of the hype cycle that we're currently witnessing is, I think, surprising. But that's not as a scientist. It's not surprising as a scientist because if you look at what's caught people's imagination, it is that which it is basically the fact they are generating content of the kind that you would generate. Right? So whether this is language in the setting of narrative text, natural language text, or whether it's images or music, the content that it generates, generative AI generates, is the kind of content that you would, or that we would. And I think that's the secret sauce behind the popularity and the surprising popularity and the why you enjoy it. You enjoy it because it basically does what you do, or can mirror you. If it didn't do that, if it reproduced content of the sort that an alien would generate, or it generated content of the kind that insects generate, I don't think you would be able to engage with it. You wouldn't be able to anthropomorphize it. You wouldn't be able to use it. You wouldn't be able to enjoy it because there would be no way of actually using it in a way that was conciliant with your generative models. It's just that it mirrors us. I think so that aspect is to me not surprising, and it really does speak to the fact that most of our generative models are probably engaged with trying to model other people. And how would we do that? Well, the first thing we have to do is the sort of the semiotics entailed by other things like us and common ground and narrative sharing and belief sharing. And of course, the prime example of that is language, which brings us back to why large language models, because it's language.
It's interesting that you say they mirror us and they do what we do and they do what we like, because also that's how we've trained them. I was reading a paper recently which said that large language models are actually like psychophantic. They kind of they tell us we're really good and they tell us we're doing things correctly, and we love that. And so that's kind of a bias in them. As a final thing, you mentioned language there. What do narratives do? How should we think about narratives in terms of the free energy principle? These guiding structures that we can live our lives by, and that can change many people's lives, and through mythology and through stories we tell ourselves.
Yes. No, that's again an excellent question. I have colleagues, people colleagues of Maxwell Ramsted in Canada, who have written very fluently about this. So there's a lovely literature. I guess what you're referring to is, on the one hand, scripts, sort of ways of living one's life that are inherited from an encultured niche construction, a transgenerational way of setting up certain ways of living and certain ways of being. I am this kind of person, and I'm going to have this kind of lifestyle because that's the kind of thing that I am, and I have selected that because these are these are the scripts that I have been afforded by fairy tales or by watching my favourite uncle or my mum behave in particular ways, or role models behave in particular ways. I think that that's a really important aspect of narratives as scripts for just ways of behaving, in terms of social norms and everything that would be necessary to specify how you'd behave in this moment and the choices that you make. But I also think that narratives, read in a more limited sense, that I usually use the word, are an integral part of these deep generative models that are future pointing, that support planning and agency. So they are, and it is interesting that temporal depth is characteristic of transformer architectures that have not just the attention heads or the attention precision weighting mechanism, but they also have this sort of autoregressive temporal depth as part of it. Which marks them out as something that again generates the kinds of content that you generate, because that's what you do. You have these very long future-pointing generative models where you go through successive states, possibly generating words as part of a narrative, as part of a sentence, but crucially having paths into the future. And I think that's what I just meant by narrative. It's a path into the future. And you get these narratives at every scale, where one step at the deepest, slowest level provides the context for a sequence of updates or steps or itinerant paths at the lower level, and so on all the way down until we actually get to the millisecond by millisecond articulation of the phonemes and my through my voice box and vocal musculature. So I think having this notion of narratives, but in a scale invariant way, in terms of this hierarchical, these deep generative models, is a really useful thing to bear in mind. And it may well be that the narratives at the very, very deepest point, at the soul of your generative model, are the kinds of scripts that you were talking about, and that cover entire lifespans.